Next, Kirchhoff's laws. In the Kirchhoff's laws, there are two types of Kirchhoff's laws. First one, KCL, Kirchhoff's current law, and second one is the Kirchhoff voltage law. The first one, Kirchhoff current law. The sum of currents entering and leaving a node in a circuit is equals to 0. That means summation of I equals to 0. In the network, in the circuit, let I1, I2, I3 and I4 are the currents at a junction or node are 0 as shown in the figure. The currents flowing towards the junction are taken as positive. That means the current flowing towards the junction means I1 and I2 is going towards the junction, is flowing towards the junction. I1 plus I2, and those currents flowing away from the junction are taken as negative. That means I3 and I4 are going away from the junction. That means I3 and I4 are going away from the junction. That means we must take negative. So I1 plus I2 minus I3 minus I4, that's equals to 0. That's equals I1 plus I2, that's equals to I3 plus I4. Thus, at a junction of a network, the sum of the currents flowing towards is equals to the sum of the currents flowing away from the junction. Next, Kirchhoff's voltage law. In any closed mesh, the sum of voltage drops is equals to the sum of all EMFs in the circuit. That means summation of IR, that means the product of current and resistance, is equals to the summation of EMFs E. In the mesh, in the circuit, in the mesh, that means mesh means A, B, C, D, A is a mesh. Before that, you must know about the sign conventions used to apply the KVL to the mesh. The fall in potential in the resistor is taken as negative. The rise in potential is taken as in the resistor is taken as positive. The rise in potential in voltage source is taken as positive. The fall in potential in voltage source is taken as negative. I am starting from A, I1 into R1. The voltage drops across R1 is I1 into R1 minus I1 into R1. Next, minus I1 into R1 means the fall in potential plus to minus the fall in potential in resistor is taken as negative, minus I1 into R1 minus I2 into R2, the same thing, minus I3 into R3 plus E. Plus E means the rise in potential in the voltage source from negative to positive, you must take positive. That's equals to 0. Therefore, I1 into R1 plus I2 into R2 plus I3 into R3, that's equals to E. In the source voltage is taken as positive while moving from the negative terminal to the terminal of the battery to the positive terminal because of the rise in potential. Next, application of Kirchhoff's laws. Using Kirchhoff's circuit laws, the various voltages and currents circulating around a linear circuit can be found. Next, we can also use loop analysis to calculate the currents in each independent loop by using Kirchhoff's laws. Thank you.